Hi guys, this is video 1-9. It should be watched Tuesday 9/20. What are the three conditions for continuity of a function? Write these down by yourself. If you did that, that'd be a great exercise. I'm going to write them down right now. Try to do it without me because that's how you'll know if you really know them or not. So f of a needs to be defined. The limit as x approaches a of f of x needs to exist. And then the third condition, the limit as x approaches a of f of x equals f of a. All right. Now what we're going to use today, we're going to focus on using this third one. Guys, if a function is continuous, then the limit as x approaches a is actually equal to the function value. So this is a very powerful part of the definition of continuity, because what this is saying is essentially if you want to find the limit as x approaches some number, instead of thinking it through with an arrow diagram, like approaching from the left, approaching from the right, very, very close to a, you can actually just plug a in. And that only works if it's continuous. All right, so I mean, take a moment to digest that if that is not clear, but this is very powerful. It says from now on, guys, if you want to find the limit of a function as x approaches some number, if that function is continuous at that number, then to get the limit, you can just plug it in, okay? So what this one is saying is that so let's write this down. Direct substitution works if the function is continuous. Okay, so what I'm saying here is that if the function is continuous, then to find the limit, you could do what's called direct substitution and just plug in the x value that you're approaching, and it's going to be the same as the limit value. Okay, only works if the function is continuous around what you're approaching. Okay, so we're only going to do two examples. This will be kind of short. All right, so example number one, let's take a look at this. We've got the limit as x approaches -2 of this polynomial here. This is a quadratic. All right, is this function continuous everywhere? Well, guys, just think about it. A polynomial, there's no holes, there's no asymptotes. This is a continuous function. There's no way, if there's no denominator and there's no radical, basically it's continuous. There might be some, that might not be always true, but for our purposes today, if you don't see a denominator and you don't see a radical, it's continuous everywhere. So is the function continuous everywhere? The answer here is yes. Now this is a little redundant, but now is the function continuous around the x value we are approaching? So x is approaching -2. So is this function continuous around -2? Well, yeah, it is, guys, because it's continuous everywhere. So that's kind of a no-brainer. So yes. If the answer is yes to this one, then this means from now on, you can use direct substitution. And what I mean by that is this. The limit as x approaches, in this case, -2 of our function is going to be the same as f of -2. All right? So this is going to be the same as if we just took that number and plugged it in. This only works for continuous functions. All right. And what do we have here? We've got 12 plus 4 plus 1, 17. Excellent. Okay. Now, example number 2. Is the function continuous everywhere? Guys, this one is not continuous everywhere because I have a denominator, and where this denominator is 0, the function is not continuous. So no, it's not continuous. So I'll say no, and let me say this. I'll say not at x equals -1. Okay? No, it's not. Not at x equals -1. Second question, though, is the function continuous around the x value we are approaching? We're approaching 5. Guys, 5 is, relatively speaking, pretty far from -1 if you consider all the infinite numbers that are between 5 and -1 on the number line. So, is the function continuous around the x value we're approaching? Yes, it is. All right? Because this is yes, we can use direct substitution. All right? So since this function is continuous at the x value we are approaching, we can use this third fact about continuity. All right? So this is because it's continuous at x equals 5 equals 5 squared plus 3 over 5 plus 1. Direct substitution. And then that's equal to 28 over 6 equals 14 over 3. And I did say to you in class once that you don't have to simplify. It's true. You don't. If you stopped at 28 over 6, that'd be good. For the AP test, you would not have to simplify this. I encourage you to simplify, though, in situations like this, because in college, your professors would not like to see 28 over 6. Okay. So, all right, there's that, guys. That was probably our shortest video yet. So the homework's going to be a little longer than usual, although not long. It's going to be page 19 all. All right. See you tomorrow.